Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning programs. This is Teacher Pasco, and today I will be with Senior 1 students in unit number 5. We have been discussing a lot in this unit. We know what a radical means. We know the formula of various radicals, their names, and today we will focus on how to write molecular formula of compounds and naming them. When you want to write the molecular formula of a compound, you have to use the radicals. And if you want to name them, you have to use the names of those radicals. So today we will have a look at how to use the radicals and the names of those radicals to write molecular formula and name the different compounds. Here we have the objectives. At the end of this lesson, you should be able to write the molecular formula of various compounds and name the various compounds. So let us start with a revision exercise. Name these particles. I've used the term particles because they may be monoatomic ions or polyatomic ions, which we usually consider as radicals. So we have SO3 2 negative, PO3 3 negative, HSO3 1 negative, Ca2 plus, and NH4 positive. Let me give you some minutes and you try to name these 5 particles. Try it, please, because the names and the different radicals, they are the ones we will use to learn the new topic of today, writing molecular formula and naming the different compounds. So, hurry up, please. You have 20 seconds remaining. We have seen all of these particles in the previous lesson. So you should be able to work them out, write their names in a very short time. Okay, so let me suppose that you have finished and we go to the correction. Particle number 1, we have SO3 2 negative. What is the name of this particle? The name of that particle, this one, SO3 2 negative, we said that when we have 3 oxygen atoms, what is the ending of the name of the radical? Remember, it is different from when we have 4 atoms. And it is the same when we have 3 atoms on the nitrogen and 2 atoms on the nitrogen. Those 2 radicals we have seen which contain nitrogen atom. So when we have 3 oxygen atoms combined with sulfur or phosphorus, the name ends with "ite." So here we have the sulfide. So our radical is the sulfide. And number 2, we have, and as I was saying, if you have 4, then it will be sulfate. It's just for a revision. And here we have PO3 3 negative. What will be the name for this second one? PO3 3 negative. The name is phosphite. Phosphite, if it is 4, then it becomes, you replace the ite with 8. So it becomes phosphate. Phosphate. And the next particle is HSO3, 1 negative. We've seen that, you can see this particle is derived from the first one. So the third particle can be written but derived from the first one. Here we have added a hydrogen atom and the charge has increased by 1 from -2 to 1 negative. And what will be the name? On the name of this particle, we add that of the particle we have added. And the particle added is hydrogen. So it becomes particle number 3, HSO3 negative. The particle becomes, on the sulfite, we add the name of this one. So it becomes hydrogen sulfide. You remember this with other particles like HCO3 negative or HPO4 2 negative. What is the name of this one? The name of this one, the part we have here is the carbonate. And when we add hydrogen, it becomes hydrogen carbonate. And with this one, the phosphate, if you add hydrogen, then it becomes hydrogen phosphate. All right? Good. And the fourth particle is Ca2 positive. Ca2 positive, that is a monoatomic ion. And what will be the name? You know the name of that particle. You can read it from the periodic table when it is not charged, and it takes the same name even when it is charged. So it is calcium. Calcium, and it is the same as how we can derive the name of various ions, monoatomic ions, like the ions in group number 1 of the periodic table. I'm saying sodium, lithium, hydrogen, potassium. So you just write the name of the element. It doesn't change for monoatomic ions, and especially in metals, the name doesn't change. So whether it is charged or not, the name remains the same. Okay? Good. But it changes for the non-metals. For the non-metals, let me give you an example. If you have sulfur, for example, with 2 negative, the name, we have seen that we add IDE. So for sulfur, it becomes sulfide. For oxygen, we have seen that it becomes oxide. Nitrogen, it is nitride. You remember all that. And that is very good. Now let's go to the last particle, NH4 positive. NH4 positive, we call this one the ammonium ion. It is a polyatomic ion, ammonium ion. Now, we have revised how to name the different particles, the charged particles. And I hope you know how you can start from the name and write the formula of the particle. Starting from the name, you can also write the formula of the particle. And I'm saying this because today we will see how we can start from the molecular formula and find the name. Or start from the name and write the molecular formula of the compound. Okay? Remember, those are the two objectives of our lesson today. So let us go to the next slide, and we see some of the characteristics, or we recall some of the characteristics of radicals. We have seen that radicals have charges. For example, this one, the sulfide ion, it has 2 negative, sorry. Here we have 3 negative, and the hydrogen sulfide, we have 1 negative. On calcium, we have 2 positive. The ammonium ion, we have 1 positive. And these charges, they are very important when we are writing molecular formula of compounds. Very soon we will see how to use these charges. But they have, before we go to seeing how we use these charges, let us have a look at the special name we give to these charges on the radicals or the ions. There is what we call valency. Valency, and the valency, it is something very important. And here let me say that it shouldn't be confused with valence. When we say valence, this second one, we mean the number of electrons on the outermost shell, on the last shell. Remember, we have seen that in atoms, we have electronic shells where the electrons are located, okay? So, if we have where the electrons are located, the different energy levels or electronic shells, of course, we will have the first electronic shell, and as we go far from the nucleus, we will reach the last electronic shell. So the number of electrons present in the last energy level or the last shell, we call that valence electrons. So valence means last, okay? Valence, the last one. So valence electrons means the electrons in the last electronic shell. And valence shell means the last electronic shell. So we understand the meaning of valence. Valence electrons means the number of valence electrons, in the last shell. And valence shell, that is the last shell, going out further from the nucleus. And now, what is valency? The first one, valency. You can see it is here. These charges show the combining capacity of each radical, and it is their valency. Valency means the combining capacity of a particle. If a particle is to combine with other particles, how many of the other particles will combine with the first one, the one which is to be combined? For example, let me say that we have sodium. How many, for example, hydrogen atoms can combine with sodium? So how many particles can combine with a given particle we are considering? That is the combining capacity, and it is shown by valency. And valence can be determined for the radicals simply by looking at the charges. So the valency of the particles we have here for the sulfide ion radical, the valency is 2 negative. And phosphide, it is 3 negative. For ammonium ion, it is 1 positive. For calcium, it is 2 plus. So the charges on the ions or the radicals show the valences of those radicals. And for elements in the periodic table, we can determine the valences simply by looking at the group number. For group 1, the valency is 1 plus 1. For group number 2, the valence is 2. For group 3, the valence is 3. And for group 4, the valence is 4. But when you go to group 5, 6, 7, then you take the number of, to find the valency of an atom in the nonmetals, you take 8 minus the number of group in which the particle is located. So if you want to find the valency of nitrogen, for example, you take 8 minus 5, because nitrogen is in group 5. So the valence will be 3. For oxygen, it is 8 minus 2. And we get minus 6. We have oxygen in group number 6. So it will be 2. You can put negative there. And we will explain why we use the negative when we will be in senior 2. That is where we will be able to understand the reason why we can use the plus and the negative in front of these valences. And for group number 8, we consider these elements to be unreactive. They do not combine easily with other elements. So we consider them to have a valency of 0. They do not combine. That is what we consider. Now, how do we form compounds? We know that when radicals combine, compounds are formed. But how do they combine? How do they combine? We go through the next slide to see how they combine. Okay? Writing molecular formula of compounds. Well, how do we proceed? We combine the radicals as follows. First, we write the valences as superscripts after each symbol. And second, we interchange the valences and write them as subscripts after each symbol. Let us have an example. We know the compound we call sodium chloride, the table salt. How do we write the molecular formula of table salt? Sodium chloride. Here there is sodium chloride, and on point number 1, this one, it is said we write the valences as superscripts after each symbol. The symbol we have here, it is sodium with a valence of 1, and we write it as a superscript. We also have the chloride ion, which has 1 negative as its valency, and we'll also write it as a superscript. On point number 2, and see here we have point number 2, we interchange the valences and write them as subscripts after each symbol. And then it becomes, we interchange. Let's say we have sodium with 1 and Cl with 1. Remember, it is 1 positive and 1 negative. We have interchanged the valences and we have written them as subscripts after each symbol. And how do we get the final molecular formula? You have to check if the valences are similar, you remove them. But if they are different, you cannot remove them. They should stay there in the molecular formula. We will see an example for that. But now, as we have 1 and 1, then negative 1 plus positive 1, we get 0, so they can be cancelled, and we get sodium chloride, and this is the molecular formula of table salt. Sodium chloride. That is the molecular formula of table salt, sodium chloride. Do you want another example? Yes. Let's have another example. Let's say we have a compound called potassium sulfate. Potassium sulfate. Do you remember the formula of potassium? It is K. with 1 positive, that is the valency. And the sulfate ion, it is SO4 2 negative. This is the valency. Now we are done with point number 1. This one, point number 1, writing valencies as superscripts after each symbol. Now if we interchange them, what do we get? We get this. Potassium with 2 here and SO4 with 1. You have to use brackets. But the 1 here, there is no need of writing 1 because it is single. It is a single particle. So when it is a single particle, there is no need of showing that it is a single particle. You know, if in mathematics, we remember when you take something, a given value, times 1, you get the same value. So there is no need of writing that 1. So here it simply shows that we have 1 particle and combined with 2 particles. So it becomes potassium. If we remove this one, which is not needed, we get K2SO4. That is potassium sulfate. Now, let's go to more examples. More examples. Write the formula of the following compounds. Potassium sulfate. You are so lucky. I've done it for you. Potassium sulfate, the first one. Now you try the second, the third, fourth, and fifth. Hurry up, hurry up. Time is running too fast. Ammonium nitrate. Remember the molecular, the formula of the ammonium ion and the nitrate ion. You write the superscripts and you interchange the valences. If they are similar, you remove them. If they are different, they stay there. But remember, if you have 1 as a subscript, there is no need of writing that value. Aluminium chloride. So let's try this. We have ammonium nitrate. It's this one. It's number 2. Number 3, we have aluminium chloride. This is aluminium with 3 positive, the chloride with 1 negative, and if you interchange, what you get will be aluminium with 3 here. We said when it is 1, there is no need of writing it. So this is the molecular formula of aluminium chloride. Number 4 and number 5, you will try them. Lithium carbonate and calcium hydrogen carbonate, you will try this one. These 2, okay? Now, let us see how we can start from the molecular formula and name the compounds. What do we do? Combine the names of the radicals. And here, you should know that we start with the name of the positive radical. We have the example here. Sodium chloride. It's this compound. So you start with the positive part, you write the name, followed by the negative part, and you combine the 2 names. It becomes sodium chloride. What is the other example we have here? We have MgSO4. The first part, which is positive, is magnesium. And the second part, which is negative, is the sulfate. So the name is magnesium sulfate. Very simple. Just like drinking water. And we have FeCl3 and FeCl2, which will be named as iron 3 chloride. And here you have to be very careful because the ions we have are from the same element, but they have different valences. So we should do what? We should indicate the valences. You remember how we named these ions, monoatomic ions, which have different charges, but which come from the same element. We said that you use the Roman numbers in bracket to show the charge on each ion. So here, this one will be iron 3 chloride, and the second one will be iron 2 chloride. Iron 3 chloride, iron 2 chloride. Now, more examples. KHSO3. What is the positive part? It is K. And what is the negative part? HSO3. What is the name of the positive part? The name of the positive part, KHSO3. The name of this one is potassium. And the negative is hydrogen sulfide. Very simple. And the second one is MgHPO4. The name for this part, the positive part, the metal one, is magnesium. And this one is hydrogen phosphate. So the name will be magnesium hydrogen phosphate. Ammonium and chloride. So the name is ammonium chloride. And as usual, number 4 and number 5, this is for your practice. Okay? For your practice, you will try them. Just combine the names. If there is a possibility of having 2 different ions coming from the same element, don't forget to indicate the valence of that part. Homework, name these compounds. Na2O, Al bracket OH3, and number 3, KCl. Exercise number 2, write the molecular formula of iron 2 chloride. And number 2, copper 2 hydroxide. You will try this when you get time, and I'm very sure you will do them well. So thank you for your attention. This is the end of our lesson. See you next time. Thank you.